So the law of sines is the sine of alpha, over side A equals the sine of beta over side B equals the sine of gamma over side C. And you go, boy, Mr. Bierschbach, your handwriting's really sloppy on that. No, actually, that is how they make their letters in this trig book. Okay? Alpha is the angle opposite of side A. Beta is the angle opposite side B. And gamma is the angle opposite side C. Okay? Now, we only use two of these at a time. So we make a proportion out of two of these. So it could be these two, or it could be these two, or it could be the first and the last. Okay? So when we have triangles, we have to just see which side is which, and then we do a lot of cross multiplication. So get out your calculators and make sure they're in degree mode, because we're going to be using them a lot. Well, you can't do this assignment without using a calculator. Okay, so we will use them a lot. Make sure you're in degree mode. Okay, so here's a triangle, and it says solve this triangle. So I want to figure out what every angle is and what every side is. Okay? Now, if you're given two angles, to find the third angle, it's the easiest thing in the world. How many degrees are in a triangle? 180. What's 180 minus 64 minus 62? 54. Okay? So finding that is really easy. Now, I want to find out what side B is. To do law of sines, you use opposites. So, to figure out side B, I want to take the sine of the angle opposite it, 62, over B, equals opposites that we know. Here's something we know. I know that the sine of 64 is opposite of 14.1. Now, if I get B equal to like 20, I'm going to know that's a wrong answer. Why? Why would 20 be a wrong answer for this? See where this is 64 and this is 62? Okay? The smaller the angle, the shorter the side. The bigger the angle, the longer the side. So if this is 64 and 14.1, 62, B should be pretty close to 14. But it has to be smaller than 14.1 because 62 is smaller than 64. Okay? You have to have a little number sense. Now, to solve a proportion, you cross multiply. So the sine of 64 times B equals 14.1 times the sine of 62. And then you divide each side by the sine of 64. They cancel, so B equals 14.1 times the sine of 62, press equals, divided by the sine of 64, press equals, and what do you get? 13.9, rounded to the nearest tenth. Okay? All right. Then we need to figure out C. Can we use the Pythagorean theorem here to figure out C? Because we have two sides of a triangle. So then to find the third side, just use the Pythagorean theorem, right? No. You can only use the Pythagorean theorem in what kind of a triangle? A right triangle. Is this a right triangle? Certainly not. It is not a right triangle. So we can't use the Pythagorean theorem, so law of sines is our greatest option. Now, can I use the answer that I just found and go the sine of 62 over 13.9 equals the sine of 54 over c. Would that work? It would work, but not very well. The reason why is this is a rounded answer. We want to use the exact answer, the exact numbers. These are exact numbers because they're given to us at the start of the problem. So you want to use what's given to you at the start, not a rounded answer, when at all possible. And we'll see when that's not possible later today. So the sine of 64 over its opposite side, 14.1, equals the sine of 54 over its opposite side, c. Now, instead of doing the long process here, okay, we want to know what c is, right? Take this times this divided by this. Okay, one more time on that. This times this divided by that. Okay, this times this divided by this. And that'll figure out c for you. So what is c going to be? 12.7. Okay, so a lot of calculating to do today. Okay, just a lot of calculator work, knowing how to set up a triangle. Now, what do you notice about the angles in this one? What's special about the angles in that one? $11.7, $114.8, and then there's a side that's 3. What's special about those angles? One of them is obtuse. One of them is obtuse. So angle gamma is obtuse. That's 114.8. Gamma is opposite of what side? What letter? C. B is opposite of B. So this is angle beta. So this has to be angle alpha. And alpha is 11.7. And A, we don't know how long A is. Okay? So we only know how long B is, and that's 3. Okay? So, what can we figure out just by looking at that? Well, if I have two angles, I should know the third angle. Because there's 180 degrees in triangle. 180 minus 114.8 minus 11.7 is 53, 54, somewhere in there. 50, 53.5. Now, is this a rounded answer or an exact answer? It's exact, okay? We didn't do the law of sines and figure out a whole bunch of decimal points. This is 180 minus this minus this. So this is an exact answer, so we can use it the whole time, okay? So let's figure out A next. Side A is opposite 11.7. So the sine of 11.7, sine of your angle over the length of the side, angle over side equals angle over side. The sine of 53.5 over its opposite side of 3. So you cross multiply. Take this times this, divide by this. How big is A? Three times the sine of 11.7 divided by the sine of 53.5. .8. That sounds right. Because 3 is small, so A is even smaller. Okay, now let's find C. We'll do the same type of thing. The sine of 114.8 over its opposite side C equals the sine of 53.5 over 3. use what you're given. You're given these two, so that's what we want you to solve. So you take this times this divided by this. When you're finding sides, it's really easy to do the cross multiplication. What do we get? 3.4. And this is 0.8. And this is 53.5. Let's just check our answers. Yeah. It says round to the nearest thousandth. We weren't looking very closely at the directions. So if we have to round to the nearest thousandth, that's 3 decimal places. So make sure you watch what they want you to round to. So we're going to skip over 3 because that's the same as the first two. Now we have some word problems. A helicopter flies from the aeroporto on a course with a bearing of 20 degrees. After flying 107 miles, the helicopter flies due east for some time. Then the helicopter flies back to the airport at a bearing of 226. How far did the helicopter fly on the final leg of its journey? Bearing and trig angles are not the same thing. Okay? Bearing and trig angles aren't the same thing. So if you join the Navy and the captain says we need to head on a bearing of 20 degrees, okay? Bearing is clockwise from north. Bearing is clockwise from north. So if a helicopter flies on a course with a bearing of 20 degrees, it's 20 degrees away from north is where it's flying. Okay? Now, it flies for 107 miles, so the length of this side of the triangle is 107. Then it flies due east for a while. I don't know how long a while is, but let's make it that long. There, that's a while. Okay? Then it turns 226 degrees and flies back to the airport. What's 226 degrees? Well, there's 90 degrees. Here's 180 degrees. So here's 226. So it goes 226 degrees from north. Clockwise from north. That is bearing. All right. So this is all we know. We want to know what this side right here is. How can we figure out how long this side of the triangle is? Well, we want to have the angle opposite of it. But we don't have the angle opposite of it yet, do we? We'd like to know this angle, because if we know this angle and this angle, then we can find this angle. Could we find this angle? Yeah. Now, here's 90 degrees. Here's 180. Going up to this east-west line here, that's 270. So he made it 226 degrees of the 270 degrees. What's left for that angle? How many degrees are left? 44. So this is a 44 degree angle. How many degrees are there in a triangle? 180. Okay? So if this, I don't know this angle down here, because 107 is the length of the side. I need to know this angle too. But if this is 20 degrees here, right here, then this is 70 degrees here, but I need to know what that one is. Hey, you know what? I know up here that if this is 20 degrees right here, by alternate interior angles, this angle right in here is also 20 degrees. And then how many degrees is this angle right here? 90. So really, this angle up here is 110 degrees. I don't even need to know that angle down there. Okay, this is a 110 degree angle up here. This is 44. 44 is opposite of 107. 110 is opposite of x. Hey, I can do law of sines now. The sine of 110 over its opposite side x equals the sine of 44 over its opposite side 107. So then you take this times this divided by this, and you figure out how long they flew on their last stretch with the helicopter. Definitely going to be longer than 107 miles. Quite a bit longer than 107. How long is that stretch? 144.7 miles. Round to the nearest tenth. Now, I bet some of you are going, geez, I really didn't catch that very well. Okay, so let's do another one similar to that. All right. So, airplane flies at a bearing of 50 degrees from north for 200 miles. Then flies east for some time. Then turns at a bearing of 230 degrees and flies back to the aeropuerto. Okay? How far did it fly in its last leg of the journey? Okay, so initially, it goes this direction, 50 degrees from north. How big of an angle does it turn when it flies straight east? Well, if it's 50 degrees here, this is 50 degrees, this is 90 degrees. So how many degrees is this angle here? 140 degrees here. And then it's going to turn at a 230 degree angle to fly back home. So if this is 90 and this is 180, 230 goes to here. So that's 50 degrees down here. So it's 40 degrees here, right? And if this is 200 miles, I have enough to figure out what x is. So the sine of what over x? What's the angle opposite of x? 140 over x equals the sine of what over what? 40 over 200. So we cross multiply. So 200 times 140 divided by the sine of 40. 200 times the sine of 140 divided by the sine of 40. What do we get? 200 on the dot. Guess what we did? I made an isosceles triangle. No, I didn't. I made a triangle that is not a triangle. Because if this is 140 and that's 40, this is 0 degrees. I made a problem that is like impossible, but oh well. But you guys get the setup, okay? Because the problem will actually work that you're given. All right. Points A and B are on opposite sides of a lunar crater. Here's a lunar crater. What's a lunar crater? A crater that's where? On the moon. Here's A, here's B. So there are points on opposite sides of a lunar crater. Point C is 41 meters from A, and angle BAC is 114 degrees. So I have to make an obtuse angle here. So BAC is 114. That's 114 degrees. Okay. C is 41 meters from A, and angle ACB is 43 degrees. So if I know this is 114 and this is 43, what's left for this angle down here? $23. That works. So the sine of 23 over its opposite side, 41, equals the sine of 43 over its opposite side. Let's just call it C. Because the side opposite of angle C would be side C. And we're looking for the distance across the lunar crater. Okay? So you just take 41 times the sine of 43 divided by the sine of 23, and we get the answer. And it's going to be bigger than 41. I bet it's in the 70s. We're close to it. 71 point, and it says round to the nearest hundredth on this one. So 71.60. 71.56. All right. The last one. The angle of elevation from the top of a tower to point A on the ground is 18.9 degrees. From point B is from a point B 33.8 feet closer to the tower. The angle of elevation is 22.8. What's the height of the tower? So we got a big tower. A is here, which makes the angle of depression is 18.9. So that means the angle of elevation is 18.9. Then there's point B, which is 33.8 feet closer. 33.8 feet closer to the tower. Its angle of elevation is 22.8. So if the angle of elevation goes this way, 22.8, down here is 22.8 as well. Okay. The height of the tower is what we want to know. So in this one, I don't know much. I know 22.8, and that's about it. Here in this triangle, I know this and this. And since this is 22.8, how many degrees are in a straight line? What's 180 minus 22.8? 157.2. So I know these two angles in this side. So if I know these two angles, I can figure out this angle. That angle up there is pretty small. It's like 4.1. I don't know. What is it? No, not 4.1. 180 minus 18.9 minus 157.2. 3.9. Okay, so that's 3.9. Now I have enough to figure out a side of this triangle. I can figure out this side of this triangle, right? So let's figure out side, let's just call it P. So P is opposite 18.9, so I go the sine of 18.9 over P equals the sine of 3.9 over its opposite side of 33.8. So if you cross multiply, take this times this, divide by this, you get P. How big is P? Should be pretty big. $161. Do we have a decimal on that at all?
It was 160.96.
Okay, so 161.0. You guys agree? We got some agreement on that. So now, how many degrees does this look to be? 90. I would say that that's a 90-degree angle there. So the sine of 90 over 161 equals the sine of 22.8 over its opposite side, x. And then we can find the height of the tower. 161 times the sine of 22.8 divided by the sine of 90. Tower's got to be less than 161. How big is it? How tall is it? 62.4 feet. We got some agreement there. And the book agrees with me too. So we are good. So that's it. You got a 6-problem assignment to take care of over the next 15 minutes or so. And then we'll move on to the ambiguous case. Okay, it is out there.